Hello there, Mr. Sutton here, bringing you the Algebra 2 4-7 homework solutions on transformations of polynomials. For the first few problems of this homework set, they want us to describe the transformation of f, represented by the g function, and then graph it. So we'll do the description first, then we'll come up with a parent table, then we will modify that to actually graph g. So for g of x, we have this minus 5 going on inside the x to the fourth function. It's an inside change, so it's horizontal, and it's opposite of what we expect. So minus 5 means we are going to be translating or shifting 5 to the right. So now my parent table for x to the fourth, I'm going to plug in with all of these negative 2 through positive 2 for my x values. So we have negative 2 to the fourth is 16. Negative 1 to the fourth is 1, 0 to the fourth is 0, and then if we do 1 and 2 to the fourth, we get 1 and 16 again. It's a symmetrical function. So let's go ahead and modify this now. And this is going to be the g function I'm doing the table for now. So if I'm translating right 5, that means I have to add 5 to all of my x values. And there's no vertical transformations that we see here, so y is just going to stay the same that it was before. So adding 5 to my x values, negative 2 plus 5 is 3, negative 1 plus 5 is 4, and then we have 5, 6, and then 2 plus 5 gives us 7. For the y values, those are staying exactly the same, so just 16, 1, 0, 1, and 16. And now to graph it all out, my grid lines have to go, they have to accommodate 3 through 7, so I'm going to be shifted a little bit toward the right with my xy axis. And then for my vertical, I need to get all the way up to 16. So probably have grid lines that go by 2s or 4s, whatever gets us there. All right, so we've got 3, comma 16 is going to be up here the way I've done my axes. And then 4, comma 1, that's like a quarter grid line here. And then we have 5, comma 0 right on the x-axis, 6, comma 1, and 7, comma 16. And then just go through those points. To graph this transformation, let's first describe what's happening. This plus 1 inside the x to the sixth function is giving us a shift left of 1. The minus 4 outside, it's outside so it's vertical, and it's what we expect, so that's going to be down 4. So left 1, down 4. The parent table for x to the sixths, we're going to plug in negative 2 through positive 2. Negative 2 to the sixth power is going to give me 64, and then negative 1 to that gives me just 1. 0 to the sixth is 0, and then 1 to the sixth is 1, and 2 to the sixth is again 64. All right, now let's modify this. This is for the g function. So the left 1 means we have to subtract 1 from the x values. So x minus 1 is going to be that new rule. Down 4 means I have to subtract 4 from the y values. So y minus 4. So subtracting 1 from all my x's, negative 2 minus 1 is negative 3. And then negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. 1 minus 1 is 0. And 2 minus 1 is 1. Subtracting 4 from the y values, 64 becomes 60, 1 becomes negative 3, 0 is negative 4, and then these values repeat, so we've got negative 3 again, and 64 minus 4 is still 60. Now for graphing this out, my grid lines, I have to go from negative 3 to 1, so that should be pretty easy to accommodate, but now these y values are kind of all over the place. We have to go from negative 4 all the way up to 60, so I'm going to have to make my y grid lines go by a little bit more than 1. So here's how I finagled this. I'm going to be going by 8s for my vertical grid lines. That'll get me all the way up a little bit past 60 as needed for this graph. So graphing these out, we've got negative 3, comma 60, so that's going to be halfway between 56 and 64 up here. Negative 2, comma negative 3 is going to be down here, a little bit less than halfway down. And then negative 1, comma negative 4, a little bit further down, that is exactly halfway. 0, comma negative 3 is right there. And then we have 1, comma 60 all the way back up here, so quite a steep climb. And then let's just connect all of those. For this transformation, we have a -2 outside the function, so that's going to be a vertical change all the way. The negative makes it a vertical reflection. The 2 makes it a vertical stretch. So vertical reflection and a stretch. So let's look at the parent table for x to the fourth. That's just all my -2 through 2 values raised to the fourth power. -2 to the fourth is 16. -1 to the fourth is 1. 0 to the fourth is 0. 1 to the fourth is 1. 2 to the fourth is 16. Now how am I modifying this? Well, there's no horizontal stuff going on with this transformation, so x is just still going to be x. I'm not going to change any of those x values. But for the y values, we're multiplying each of these by -2. So -2y. So my x's, I'm just going to rewrite the -2, -1, 0, 1, and 2. No change there. For the y values now, -2 times 16 is -32. Times 1 is -2. 0 is still 0. 1 is still -2. 16 still becomes -32. Graphing all this out, I need to be able to go from -32 all the way up to 0. So I'm going to make my grid lines vertically go by 4s. That ought to give me enough space to fit everything here. So we've got -2, comma, -32 down here. And then -2, or -1 rather, comma, -2. That's all the way up here. We have 0, 0, 1, -2, and 2, -32. And then just go through those. To transform the graph of x to the fifth according to this g function, let's first write out the transformation that's happening. This 2 inside the function is actually, it's opposite of what we expect, and it's horizontal. This is going to be a horizontal shrink that's going on there. And the -3 outside is translating us down 3 units. So let me do my parent table of x to the fifth. That's going to be -2 through +2 raised to the fifth power. -2 to the fifth is -32. -1 to the fifth is -1. 0 to the fifth is 0. And then 1 to the fifth is 1. And 2 to the fifth is +32. So this one is not vertically, this is not a left-right symmetrical. This is point symmetry that we've got going on with this one. So let's transform this now. For my rules, since I'm shrinking vertically, this 2 means that I'm actually multiplying my x values by the reciprocal of 2, 1/2. So we'll do 1/2 x, and then this -3 means we're doing y -3 to shift everything down by 3 units. So 1/2 times all my x values, -2 times 1/2 is -1. -1 becomes -1/2. 0 becomes, well, still 0. 1 times 1/2 is 1/2, and 2 times 1/2 is 1. For my y values, we have -32 minus 3 is -35. -1 minus 3 is -4. 0 becomes -3. 1 becomes -2. And 32 becomes 29. Graphing all this out, I have a very compressed horizontal sort of graph. I could make my grid lines go by 1 or something even smaller than that if I wanted to. We'll play it by ear. For the y values, I'm going to need to make those go by quite a bit because we're going all the way from -35 to 29. So the way that I managed this, I actually did make my x values go by 1/2, so I can graph that a little more finely. Now for the y values, I decided to make these go by 5s, so I can get all the way down to -35 and all the way up to +35, a little bit past the 29 that I need. So graphing all these out now, we have -1, comma, -35 all the way down here. Actually, a little further down. There we go, -35. And then we have -1/2, -4 right there. Let's see, 0, -3 is somewhere over there. It's very, very precise at this point. 1/2, -2 is right about there. And then we have 1, comma, 29. That's almost 30 up there. And then just going through all of these points, that gives us our transformed x to the fifth. For this problem, they want us to write a rule for this g function, which is just 3 times this f of x function. So I literally just need to do 3 times this whole expression here and distribute that. So that's 3x to the fifth minus 6x plus 9. On this problem, I have this f of x function, and we have a g function that does negative f of 2x plus 1. We want to write a rule for g. So there's three things that are actually going on in this one. One thing is I'm replacing the input for the f function with 2x instead of x. So all of these x's are going to be parentheses with 2x's. Also, after I've done all of that, this whole thing is going to get multiplied by a negative 1. And after I've done all of that, I'm going to have to add 1 at the very last minute. So here's what all of this looks like kind of all at once. Let me just break it down here. So this negative out here, this is the negative f of 2x. Again, we have 2x going in for all of the x's individually. And then again, we have this random plus 1 at the end. So I'm just going to kind of do this all at once. I have to start by doing my exponents. Then I have to do a little multiplying, and this negative is getting distributed at the same time. So a lot of things happening here, a lot of moving parts. Let's start with this exponent. 2x to the fifth is 32x to the fifth. Half of that is 16x to the fifth, and then this negative gets distributed. So negative 16x to the fifth. Next up, we have 2x to the third. That's going to be 8x cubed, and then we have to negate that. And then finally, we have a negative 8x right here, but we have a negative outside being distributed, so that's actually now a positive 8x. And then finally, this negative gets distributed to the negative 4. That becomes a positive 4, but this plus 1 gets added at the very last minute, so that's actually going to become a positive 5. And that incorporates all those changes. For this problem, they want us to write a rule for g representing these indicated transformations of this f of x function. So there are three transformations happening. We have a horizontal shrink by 1/3 and a translation 2 units up, and then that's all being followed up by a reflection in the x-axis. So these first two, the horizontal shrink and the translation, those affect different directions on the graph, so they could actually happen at the same time. They're independent of each other. This reflection in the x-axis, that is a vertical change, so that's non-negotiable. That's going to happen after we've done this translation. But I'm going to just do three new functions to represent each of these three changes. Again, the first two could happen in either order, but this reflection in the x-axis has to happen last. So let's do the horizontal shrink first by 1/3. So if I'm shrinking by 1/3 horizontally, that's going to look opposite on the inside. I'm actually going to have to multiply the inside x by 3. So I'll create a g function that does this. I'm going to say that g of x equals f of 3x. And then I'm just going to replace all these x's with 3x's. And then simplify a little bit so I have a clean slate for the next transformation. So 3x cubed is 27x cubed. 3x squared is going to be 9x squared, times 2 gives us 18x squared, plus that, and that negative 9 is still there. Another transformation they wanted us to do is this translation, 2 units up. So I'm going to create an h function to handle that, and that's just going to be the g function plus 2. So all of this stuff plus 2 is going to look very similar. The only change is that this negative 9 is now going to be a negative 7. And then last but not least, we have that reflection in the x-axis. So I'm going to create another function called the j function that's just going to negate the h function, because that's what a vertical reflection is going to do. So we just need to do negative all of this h stuff here that we just came up with. Distributing that, we have negative 27x cubed, negative 18x squared, and then positive 7. And this is our final function. This problem, which is in the honors problem set, involves a pyramid. Ironically, we don't actually need this diagram at all. It's just kind of there to explain where they got this formula. This formula is the volume of the pyramid if we plug in something with feet. So if I plug in, for example, 2 feet to this, it'll tell me the volume of this pyramid. And it's all based on the dimensions of this pyramid, but we don't need to super break down where this is coming from. here's where the problem is. So the function w of x, they're saying equals v of 3x. That's the volume of the pyramid when x is measured in yards. So if the numbers I'm plugging in are no longer feet numbers but yard numbers, the actual distance has been tripled because we have 3 feet in a yard. So they just want us to write a rule for w and then find and interpret w of 5. Well, if I'm just plugging 3 in for the x's, I can just plug 3 in for these x's here. So we have 3x cubed, which is going to be 27x cubed. And then we have negative 4 times 3x, which is just negative 12x. To do w of 5, I just have to plug 5 in now for these x's. And, I mean, you might be able to do this in your head. I can't. I'm going to go to Desmos for this. So just to be super fancy on my scientific calculator, I'm going to write the w function out. So w of x equals 27x cubed. There we go. Minus 12x. And then I'm just going to plug 5 into this with function notation. This just makes sure that I don't mess anything up. And that comes out to 3315. So 3,315. They wanted us to interpret this. So this is supposed to give us the volume in cubic feet of the pyramid if we plug in something in yards. So this is saying if I have 5 yards for my plug-in value here, that I guess that's the height of the pyramid is 5 yards, then that would mean that we have a volume of 3,315 cubic feet.